I'm going to do several examples of writing a function in vertex form, and specifically writing a function in vertex form requires using something called completing the square. So the directions ask me to complete the square to write this in vertex form, and probably to find the vertex as well. Vertex form, you have x minus some value squared, maybe multiplied by a coefficient out in front, plus k. The vertex is going to be at h comma k, which is basically the opposite of this value, and then that value right there would be your two coordinates of your vertex. This all uses something called completing the square, which you can actually kind of generate. For example, if I have the quantity x plus 5 squared, that's the quantity x plus 5 times the quantity x plus 5, which is x squared plus 5x plus another 5x plus 25. If I have something like the quantity x minus 4 squared, we get x squared minus 8x plus 16. And you can keep doing this over and over again. The important thing is that you see this value gets doubled to give you that coefficient there, and you can see the same thing happening right there. And that value gets squared to give you this value right here. And so we can kind of use that idea. Basically, if I want to write it in this form, I have to do what's called completing the square. And I have to figure out what this constant value would be. You'll notice that's not a perfect square, so that this would factor as a perfect square. Okay? Usually what I would suggest first, get this constant value off that side of the equation. So I'm going to subtract the 7 from both sides. Okay? And I get y is equal to, specifically y minus 7 equals x squared minus 6x. Okay? This value here is double that value in parentheses, and that's the value that gets squared to give you the leading coefficient. So you're going to divide by 2, gives you negative 3. Negative 3 squared is 9. Okay? I can't just add in 9 to one side of the equation. If I add in a 9 over here, I have to add in a 9 also over on this side. And that's going to change my equation a little bit. It's going to be y plus 2. This now factors. That's the quantity x minus 3 times the quantity x minus 3. It's the square root of that value, or half of this value. I want the y isolated, so I'm going to subtract 2 from both sides. Y is going to equal the quantity x minus 3 squared minus 2. The vertex is going to be the opposite of this value in parentheses, and then that value outside of parentheses. So that is a horizontal shift to the right 3 units, and a vertical shift down 2 units. So the vertex is at 3, negative 2 when I write this thing in vertex form. Oh, by the way, just to toss out one more example of this basic type, I can do a vertex form equation writing this, or completing the square. If I have something like x squared plus 5x plus k, and I just want to find the value of k that will complete the square, you're always dividing this by 2 and squaring. So in this case, that would be 5 halves. If you square 5 halves, you end up getting 25 fourths, and you just end up with a value of 25 fourths there. In factored form, you're going to take the square root of that. Of course, the square root is going to be 5 halves, so it's going to be the quantity x plus 5 halves, quantity squared. Just to toss that out there, the fact is it doesn't have to be an even value. You can still complete the square. I have another example of completing the square. This time I have a leading coefficient, and that changes the game just a little bit. Same kind of thing before. You want to start out by subtracting your constant value from both sides. I'm going to have y minus 37 equals the 2x squared minus 16x. Now the big thing here is you can keep this pattern pretty much the same if you just get rid of the leading coefficient. So I'm going to divide this entire half of the equation by 2, and remember that's all terms over here. And I'll also divide, because I have to balance, the other side of the equation by 2. I'm not going to simplify this. I'm just going to leave it in that form, because later I've got to isolate that y value again, and I'm really just going to undo all this later. Everything over here gets divided by 2. So I've got y minus 37 all over 2 equals x squared minus 8x. Now I can complete the square. And so you follow the pattern. Half of this value squared, that's going to be negative 4 squared is 16. And be careful here. If I add 16 to this side of the equation, I have to add 16 over to this side of the equation. Again, notice, I'm just leaving everything in that form. I'm going to finish this thing out a little bit later. In factored form, this factors as the quantity x minus 4, quantity squared. I can go ahead now and subtract the 16 from both sides, and I'm going to get something that looks like this. So I'm going to have y minus 37 all over 2 equaling this now that the 16 is back on the other side. I can double both sides. That's going to give me y minus 37 is equal to twice both terms here. That's going to be 2 times the quantity x minus 4, quantity squared. Notice I'm not distributing. Order of operations requires that I distribute that first. I don't need to do that. Remember, I'm doubling both parts here, so that's minus 32, and now I'm going to add 37 to both sides, and I end up finding out that y is equal to 2 times the quantity x minus 4, quantity squared, plus 5. And that's my final function. Vertex going to happen at positive 4, positive 5. Okay, so very much the same as what I did in the first example. The difference being that you first get rid of your constant, and then you divide by that value. And notice it stays here, it doesn't go away, stays in the equation, later gets multiplied back into it after I've gone through the completing the square steps. Here's an example of solving a quadratic by completing the square. Now, before I say this, let me give you a warning. This is not the most efficient way to solve a quadratic. Basic factoring is the quadratic formula. Both of those processes are going to be more efficient. This is more of a last option, or if you run into some kind of problem that asks you to solve it using completing the square, then at least you know that the process can be used for that. And of course, keep in mind, the quadratic formula is really just a generic version, ax squared plus bx plus c equation, in which they solve for x by completing the square. So it actually comes from that. It just puts all the steps into one big equation instead. So big thing here is we don't have to worry about a y variable, which means we're going to be able to simplify a lot more things as we go. First of all, I like to get rid of that constant value off one side of the equation. So I have 2x squared minus 9x is equal to 5. Okay, now I divide everything by 2. So I'm going to divide this side by 2, this value by 2. That's going to give me x squared minus 9 halves x is equal to 5 halves. I complete the square. I take half of this. Okay, that'd be multiplying by half, basically. So half of that would be negative 9 fourths. And I square that, which is going to be 81 sixteenths. So it's plus 81 sixteenths. Okay, I add 81 sixteenths over here. I have to add 81 sixteenths over here as well. Okay, now I can go through the process of finishing this thing out. A little bit of simplifying here. I will actually write this as a perfect square. It's going to be x minus, it's going to be the square root of this, which is 9 fourths, quantity squared, equal to, on this side I need a greatest common, I need a common divisor, need a common denominator here. It'll be 16, so I multiply both of these by 8, and that's going to result in, let's see, it's 40 plus 81, it's 121 sixteenths. Now, here's where the solution method comes into play. You're used to solving quadratics by getting the function equal to 0, and that's going to change in this example. Notice, I only have one x variable, and since there's only one x variable, I should be able to solve my function just by working backwards. Okay, and that's exactly what I'm going to do. I'm going to take the square root of both sides, and here's where you have to be careful. Remember, there are 2 possible square roots. There's a positive square root and there's a negative square root. So what do I get over here? Well, basically the square root knocks out the squaring. I get the quantity, erase this here. I get the quantity x minus 9 fourths on the left side equals the positive or negative square root here. And remember, this is the same thing as taking the square root of 121 over the square root of 16. That's just going to be 11 fourths. Okay, so I've got 2 little equations here to solve. I know that x minus 9 fourths is equal to 11 fourths. I know that x minus 9 fourths is equal to negative 11 fourths. We've already got common denominators here. So add 9 fourths to both sides here. That's going to be x is 20 fourths, which is, of course, 5. And over here we can add 9 fourths to both sides. X is going to be negative 2 fourths, which of course is negative 1/2. and there are your two solutions. So not particularly fun and easy, but it's not really that time consuming. And you just saw an example here that had fractions. Much easier when you don't have fractional solutions. So it's definitely a useful process, but again, not the most commonly used one.